Hello students, today's agenda is to check your homework. We're going to learn about population growth and decay, and you will be able to do 8.8. Today students will be able to calculate population growth and decay from word problems. So let's start with one problem. It says California has a growth rate of 0.9% per year. In 2015, there was 38.8 million people, 3.8% growth attributed to mini boom since 2010. Okay, so just for the sake of to make it easier, now I don't want you to round in the word problems, but right now I'm just gonna do that. 0.9% is very close to 1%. Okay, so we're gonna round it up only for this exercise. Okay, so if in 2015 the population was 38 million, what would be the population in 2016? Meaning right now, what's the population if it was to grow at the same rate every year? Okay, so we can take f of 1. Why f of 1? Because it's 1 year later. Okay, and it's gonna be always your initial point, which is 38.8 million is the same as 38,800,000. Okay, and let me ask you, if we multiply by 1, or even before we go to this, what would be 1% of that? Well, let me see, you can see both of these. There you go. 1% of 38,800,000 would be 38,800,000 times 1%. Now remember that 1%, we just bring it back 2 spaces. So in decimal form, 1% would be 0.01. So we're going to multiply this times 0.01. And that's the 1% population growth. So this amount would be added to the population of 2015. That will give us the population for 2016. So in 2016, and we'll come back to this, it's going to be this amount plus 388,000, which is equals to let's see, 39,188,000. Okay, so that's the population of 2016. Okay, which is 39,188,000. Okay, so that's the population. Now, if I wanted to get the population for 2017, would I just add the same 1%? The answer is no, because that 1% will represent, okay, I'm just checking that the sun doesn't affect the video. Okay, that will represent the 1% of this. But if we're talking that there is each year there is a 1% growth, then we would have to take the 1% from this. And that's where the functions are beneficial, because that way you don't have to be calculating, okay, I'm going to multiply this times the 1% and then add it to it. And then, and then for the next year, I would have to multiply by 1% the new amount or the new population times 1%. And to figure out each year, you would have to do that, okay? Multiply the current, for that 1 year, current population times the 1%. And that will make it tedious. So that's why it's better to come up with a function, which is f of years, I guess, will be equal to the initial point when we start calculating, which is 38, instead of 0.8 will be 38,800,000, which is my initial point. This is the same as 38.8 million, times, what would be the base in here? And some people would say, oh, it would be 0.01, which is what we multiply by in here. However, that will mean that we would be killing the other 99% of the population, because this includes only 1%. If we multiply by 0.01, we will be killing 99% of the population. So we need to include the population that there is by putting a 1 in there. So include this population plus the 1% that we add on, okay? 1.01, this represents the 1% growth, and this 1 represents that we're multiplying 1 times also what exists in 2015, okay? And for the cycle, it says that the rate is per year. So basically, we just put the same variable in here. If it says every 6 years, then we put y over 6. If it's every 9 or 10 years, we would put y over 10, okay? But in here is every year, it grows 1%, we just put the cycle, okay? So that will make it easier to figure out for 2017, because it's 2 years later, so this will be replaced by f of 2. So f of 2, meaning 2 years later, the population will be the 38.8 million times the 1 times 0, 1 to the second power, okay? And 38.8 million times 1.01, the key for power, and it's 2 years, so that will be, the population would be 39,579,880 people in 2017, okay? Now, what about the population in 2020? Okay, whoops, that we already know. So 2020 means in how many years? Okay, from 15, 16, 17, 18, 19, 20, that means 5 years later. So it's going to be f of 5 is equals to the initial point. As you can see in all of these ones, we're repeating same concepts, it's just adding a little bit more knowledge, right? In here we include the 1% plus the one population that we already have, okay? So we keep applying similar formulas, and this will be to the 5th power since it's 5 years later. Again, 30, oops, okay, 38 point times 1.01, which includes the population that existed at the beginning plus the 1% growth, to the power of 5, meaning 5 years later, the population will be 40,779,100. It says 189.94. Let's see, can you see that? However, we cannot cut people into pieces, okay? So we're gonna say that it's 190 people, okay? 190 people. Okay, what about in 6 months after they take count of the population? Well, 6 months, if this is per year, the growth is per year, 6 months is 0.5, right? 0.5 of the year, so it's gonna be f of 0.5 or f of 1/2, both are correct. So f of 0.5 is equals to the initial point times the base, which is 1.01, to the 0.5. Okay, so the initial point, which is 38.8 million, times 1.01 to the 0.5, because it's only half of the year. And so the growth is going to be 38 million. So basically 38.9 million, right? 38,993,517. And we're going to leave it at 17 because this is 4. And if it's 4 or less, we round down. Okay, so it's going to be 517. Okay. What was the population 1 year before 2015? So in 2014, basically, what was the population? If you recall from previous lessons, we say that in the past, we use negatives. So basically, f of -1 will represent a year ago. If it's a -5, 5 years ago. If it's -6, 6 years ago. Okay, so f of -1 is equals to the initial point times the population that existed in 2015 plus the 1% growth, but to the -1 just to know how many people there were last year. Well, not last year from us, but the year before 2015. Okay, so we put 38,000,000 times 1.01 to the, let me see if I can put negative, there you go, you put a minus in here, -1, okay, and that's equals to, so there was a little less than 38.4, I mean a little bit more than 38.4 million, okay, so in 2014 there was 38,415,841, and this rounds to 42 people because that's a 5, so 842 people. Okay, so that was the population for 2014. Okay. let's go with another example. So in 2015, Spain has a population of 47.6 million. Spain has a population decline of 18.3% per decade. Okay, so there are two things going on in here. The first thing is that it says there is a decline. Okay, a decline of 18.3. So it's going to be a decay. If we were to graph this information, it would go down. Oh, excuse me. The other thing is that it's not per year, but per decade. Okay, that means every 10 years. So similar to before, what we did is we kept the 1 and we added the 1%, right? So in here, we're going to have the population once, but we're going to subtract the 18.3%, which in decimal is going to be 1, 2. So minus 0.183. Okay, so we're going to put 1 minus 0.183. Okay, and so that gives us, I don't know if you can see, that gives us 0.817 as our result. So basically, what it means is that 18.3% of the people leave, but then the people that are going to stay in Spain is going to be 81.7%. Okay, 81. If we move it like this to make it into a percent, it will be 81.7% stay in Spain. Okay, so with that, our base would be 0.817. So let's start. So our function would be, let's say, population per decade is equals to the initial point, which is 48.6 million, 47,600,000. Okay, so that 47.6 million, this is what it means. Times the base, which is the people that stay, is 0.817, meaning 81.7%. And in here we're gonna write D over 10 because it's every 10 years. Remember that for our cycle, we put it over how often things happen, okay? Okay, so how many people will there be in 2020? Okay, how many people in 2020? We know that this started in 2015. For 2020, it's going to be 5 years. So we say P of 5 is equals to the 47.6 million multiplied by the 81.7% that stay. And in here we replace this 5 on D over 10, which, if you recall, this can be simplified as the decimal, which is 0.5. Okay, so that it makes it easier for us. So we multiply 47,600,000 times the people that stay to the power of 5 over 10 is 0.5, okay? Equals, And that will be after 5 years. See how it went down from the initial point? Now we only have 43 million. Again, we're going to round because we cannot have pieces of people as population. And it rounds up to 43,024,713 people. Okay. What about in 2050? Well, 2050, from 2015, you can do the math, but I'm going to tell you that that's 35 years later. So P of 35, okay, from 2015 to 2050 is 35 years later. We have the same initial point and multiply by the same base because it's 81.7% of the people that stay to the 35 over 10. Remember that we always put it because the cycle is every 10 years. A decade means every 10 years. And if we, you can always divide. You are able to use calculators for this unit. It's going to be 3.5. But a trick is that whenever you divide by a number with 1 and 0, all you have to do is move the decimal back one space. And if you're multiplying, move the decimal space 1 to the front. Okay, if there are 2 zeros, move the space, the decimal twice. And so now we can plug it into the calculator. So it's going to be 47,600,000 times 0.817 to the 3.5, which is 3.5 decades. Okay, so the population, wow, look how it's less than half already after 35 years. So 23,463,000, 32, it rounds up to 33 because of the 9 in there. Okay, so that's how many people there will be in Spain after 2050 if this continues the same pattern. What about 30 years ago? 30 years, no, not 30 years ago, 30 years before 2015. So 30 years before, what was the population 30 years before? So again, remember that in the past, we're going to use negative numbers to represent that. And so we say the population of 30 years ago was the initial point, meaning the population of 2015 multiplied by the decline. And if it's in the past, since it's going down, that means that it's going to be more, right? And 30 years ago means negative 30 over 10, which is equals to negative 3. So now we plug that in, and it's 47,600, 1, 2, 3, times 0.817 to the negative 3. Okay? And so, oh, wow. Okay, so the population was 87,285,000, and it rounds up to 235 people. So that's how many people there were in, it doesn't say, well, it sounds like in 1985, I believe. Okay? Okay, so I hope this helps to be able to work on 8.8, and you're all set.